Okay, we're graphing quadratic functions. You're going to have two types of problems in this section. You're going to graph quadratic functions using a table method, and then they're going to ask you to find the y-intercept, axis symmetry, and the vertex. But then there's a second type of homework problem where we're going to find and interpret the max and min values of a quadratic function. So let's get started. Y equals 3x squared. This will make a parabola. It's a quadratic function. We're going to use this table to get our 5 order pairs, and then we'll be able to see our parabola. So each one of these is a math problem. So we're going to start with -2, and we're going to put -2 where the x is, right here. So the math in this, we're going to put -2 squared, which is 4 times 3, that'll be 12. Then you go to the next one. So -1 squared is 1 times 3 is 3. 0, easy math, 0 times 3 is just 0. And then the 1 will give you 1, and 1 times 3 is 3. 2 squared is 4, and then 4 times 3 is 12. You should see these numbers appearing as long as you're sticking with the -2, -1, 0, 1, 2, then you're going to see these numbers are going to be very symmetrical. And we're going to see a nice picture when we graph it. So I'll start with -2 up 12, which is off my chart. So then let me do -1, 3, 0, 0, and then 1 up 3. And again, the 2 would be way up here. So we do have enough to see our parabola. We know it's growing, and it's going up like that. And this is the worksheet that you're going to be doing for homework. It's got 5 problems, and I just want you to graph it on graph paper. And you need at least 3 order pairs like I have to see the picture. If my other 2 points would fit, then I would have 5 points and it would look better, but 3 is good enough. So the next problem I want to do, it's got a little bit more to it. 2x squared minus 4, so be real careful with your math. And then you can see on here I've got 3 things over here to the side that I'm going to have to find after I get my graph done. So again, careful with the math. So I'm going to take -2 and -2, and I'll do it up here, squared and then minus 4. So that will turn into 4, and then that will be 8 minus 4, so I get a 4. Let me come down here and I'll do the -1. So I'm going to go back and put -1 where the x is. So that'll be 1, and then 2 times 1, 2, and then 2 minus 4 is -2. 0, nice, you put 0 in there, it all falls out, so you end up with -4. Now these next two, because I'm symmetrical here, should be the same numbers of above. So let's see what happens. So if I put the 1 squared, I get 1, and then 2 times 1 is 2, and 2 minus 4 is also -2. And then this one should match this guy. So 2 squared is 4, 4 times 2 is 8, and then 8 minus 4 is 4, and they are. So what I'm going to do is graph these 5. I think they'll all 5 fit here. So -2 up 4, -1, and then down -2, and then 0 is all the way down here, -4, and then 1, -2, and then 2 up 4. And you can see with the 5 points it looks much better. You can just draw these and make sure your bottom part down here on the parabola is always curved. It's not a V. It makes like a U shape, so make sure it's curved. Now, this will be the second part of that assignment on that worksheet. What I'm going to have you do is answer the y-intercept, the axis symmetry, and the vertex. So let me point out what each of these are. The vertex, let me put this here, is the point at which the parabola starts growing. So that vertex, it's actually right here on my table. And so sometimes I'll label it with a V just to remind myself that that's the vertex. Now the other thing, so I got that one taken care of. The y-intercept, in order to solve for the y-intercept, I put that down here, so you put this in your notes. To find the y-intercept, you let the x be 0, and then you solve for the y. Well, you can see this is your y-axis. Remember that. So if this is the y-axis, it's crossing at -4. So the y-intercept is -4. So we got our vertex. It was 0, -4. Now the axis symmetry. The axis symmetry is always on a parabola, and it's right in the middle, and it's going straight through the vertex. Sometimes you'll see this drawn in textbooks. They'll use it's like an imaginary line. They use a dashed dotted line for it, but that's your axis symmetry. What that means is you can pull that parabola from here to here, and all the distances are the same away from this axis symmetry. So it's a really cool thing. So to write the axis symmetry, you have to write the equation, and that is a vertical line, and all vertical lines are x equal, and it's going through the x equals 0, and so that would be your axis symmetry. And so that's how you answer that type of question. So you'll already have the graphs done on your worksheet, so the next thing you'll do is go to each one and just put those 3 things on each of those graphs. So that's how you'll handle those. Now let me get to the max and min problems. So when you do a max and min, it depends on what kind of parabola you get. If you get one that opens upward, then you have a minimum value. If you have a parabola that opens downward, then you're going to have a maximum value. So the 2 I just did, they're opening upward, so you have a min value. And so what we're going to do on those problems, they're going to be in the textbook. They're going to ask you to graph the parabola out, and I'm going to let you use your graphing calculator, and then you're going to go locate if it is a max or a min. In this case, if you have this sort of picture, then you're going to go find the min value here, and then this would be your max value on this one that goes downward. By the way, to get a downward, the coefficient on the x squared, if it's negative, for instance, like a negative 2x squared, then that's the type that would go downward. So if that leading coefficient is ever negative, then it will go downward. Okay, so let's practice some. Have your graphing calculator out, and that's what we'll use here. So this is the first one. So I'm going to show you how to put that on the graphing calculator. So I'm going to let you copy that down, and then I'm going to go to my graphing calculator. I'm going to put it in. You're going to see what it looks like, but they don't tell you if it's a max or min, but just by looking right here, I know it's one of the parabolas that opens this way, so I know I'm going to be looking for a min value. And so you can already kind of write it down. You can go, oh, well, this is a min value, so I'll just go ahead and write min, and then we'll go graph it on the graphing calculator. So that'll save you some time. Okay, so here it is, 3x squared plus 12x plus 8. To get the x squared, you go right there. Here, I'll just redo it. So 3x squared plus 12x plus 8. And then you hit graph. And there it is. See, it's opening upward. And so we're down here, we're looking at this little spot right here. And you can almost estimate it. You can see here, it's going that way. The vertex is at -2, 4. But if you want to know for sure where it is, remember, do second and table. And you're going to see the vertex right here, -2, -4. And look at this table. See how there's 2 8s, there's 2 -1s, and if I push that up, you would see there's a 23 and a 23. So where it begins is right here at the -2, -4. So that's your vertex. But what they want to know is the y value. So remember that when they want to know the min value, they want to know what's the lowest point on the y. And so our vertex is -2, -4, and that min would be -4. So let's go back and write that down. So vertex, notice I labeled it with a V, and then the answer to the question is where's the min, and the min is your y value. So it would be your -4. So let's do another one. Oh, before we do that, they do ask you for the domain and range. Okay, so we're gonna do those pretty braces. In this case, domain, you could actually use all reals. You can use any x value. Let me go back and show you that on the table here. So let's go to the graph. All of these x values show up on this parabola. No matter which x value you pick, there's going to be one. You can see it on the table. All the x values, like I can arrow up, and I can see all of them. So this is all reals. Now when it comes to looking for the The range, you can already see in the picture, let me go back to the graph, that not all the y values are being used. Like these y values are not being used. The y value starts being used at -4 and above. And so we're going to go back to write that down for the, we're going to say y is greater than or equal to -4, because all the y's up above -4 were being used and -4 was being used. So that's how you would answer the domain and range. So let's do another one. Y equals -2x squared plus 8x minus 1. I'll go ahead and tell you this one is going to open downward. So we're looking for a max value. Okay. So let's go ahead and write that down. Let's go sketch it out. So -2 plus 8, -1. So -2 plus 8x and then -1. Let me make sure that was right. Whoop. Yep, that's it. Okay. So hit graph. It's going to go upside down. And remember, we're over here. We're looking at this vertex point. And it looks like I'm going to estimate it. 1, 2, 3, 4, 5, 6, 7. Let me go to my table. And is that the answer? Look right down here. Look. That's the vertex, 2, 7. And you can see that it keeps doing all that symmetrical numbers from that vertex right there. So that's what we'll say for our max value is at 7. So let's go back and write that down. So max is at 7. And now let's do domain and range. Again, the domain is all reals. And then the range, let's go and look at our graph again. For the range, go to the graph. And we're looking at these y values. All the y's through here are being used up until the spot. So at 7 and below, so we're going to go back over here. And we're going to say y, all the y's less than or equal to 7. And that is your range.